question number 2. Again, we have a smooth sphere. It is moving on a smooth horizontal plane and it is moving with the speed u. So we know it is going to collide. So it's a smooth wall. It's moving with the speed u. At the instant of collision, the direction of motion of s, it is making an angle 30 degrees with the wall. So I know that the speed of approach is 30 degrees. Once I get the 30 degrees, the next thing that I immediately do, I know that this is u sine 30. I know that this is u cosine 30. Immediately after the collision, speed of s is 7/8 u. So we're going to call this as v, and v is 7/8 u. We have to find the coefficient of restitution between s and the wall. Right, so in this question, because it is about finding coefficient of restitution, the first thing that we know is we can figure out what is the horizontal component here. So because this is u cosine 30, we know that this would also be u cosine 30. So that is one thing that we know. The next thing that we know is, so let's just write this as v if it makes things a bit easier. So I know this is v, and I also know this is v, or I know that this is e times u sine 30. So I'm trying to find what is e. So what I know is, if I know what is y, I know what is x. If I square them and if I add them, I should be able to get what is e based on, Pythagoras' technique or the idea of vectors. So squaring and adding, I can say e squared u squared sine squared 30 plus u squared cosine squared 30 should be equal to v squared. So we know that v is 7/8, so v squared would then be 49/64 u squared. That means we can now cancel off u squared, u squared, u squared, which then gives us e squared. Sine 30 is half, so e sine 30 squared, that will be 1/4. So the u is all the u's are gone. We are dividing throughout with u squared, so that is gone. Cos 30 is √3/2, so cos squared, that would be 3/4 is equal to 49/64. All we have to do now is 49/64, subtract 3/4, and then times that with 4. Finally take that answer and then square root the answer. So e would be equal to 0.25. Am I happy with my answer? The answer is yes, because we know that e is usually in between 0 and 1. So e here would be equal to 0.25. So what technique did we use in this question? First thing that I did, I knew that the horizontal component doesn't change, so we kind of extend that. and then the vertical component, whatever was the incoming, I times that with e. I got that as my vertical component, that is y, and then because I knew what was v, I was then able to do y squared, square root of x squared plus y squared. That is v. So that is question number 2.